Hello, this is a video lesson on 9.2, the binomial theorem. By the time you're done watching this quick video, I hope that you'll be able to expand the power of a binomial using the binomial theorem or Pascal's triangle. They will also find, or you will also find the coefficient of a given term of a binomial expansion. To start, here's just powers of binomials, kind of an example for you to look at. What we have here is if we expand a plus b to the nth power, where n can be 0, 1, 2, 3, 4, and 5 in this example, here's what you get. If you raise it to the 0 power, it just equals 1. If you raise it to the first power, well, you just have 1 times a to the first times b to the 0 plus 1 times a to the 0 times b to the first. And if you expanded that out, or if you simplified that, it becomes just a plus b. And then continuing with that pattern, a plus b squared, notice how you take you'll have 1 times the first term squared, the second term to the 0 power, then that a is raised to the first, which is 1 less than 2, and that b is raised to the first, which is 1 more than 0. And then on the third one, you reduce the exponent of the first term again, and you increase the exponent of the second term again, which ends up equaling a squared plus 2ab plus b squared. That's a b squared. And so on. So you can look at this pattern and notice how that first term, whatever degree the binomial is raised to, the first term starts at that, and then it decreases by 1 for each term we go across, and then the second term in the binomial starts at 0. Use a different color for that. Starts at 0 and increases by 1 as we go across. And then what you also notice is there are these other numbers out front. 1, 3, 3, 1. Next one it's 1, 4, 6, 4, 1. Next one, and so on. Well, where those numbers come from has to do with the binomial coefficient. A nice way of getting that binomial coefficient is to use what we learned about combinations. That coefficient, when we have a binomial a plus b to the n, the coefficient that we need to use is found by taking whatever n is and then having the r be 0, 1, 2, 3, all the way up to n. So for instance, if we look back up here, move some of this stuff out of the way. If you look back up here, we're to the 5th power here, so that number up front, that 1, that comes from 520, which is the same as 520. This number out here is 521. This number is 522. And so on. You keep going, that's where you can get that number from. So that's a nice quick way of getting the numbers we need in expansion. A real quick way of doing that is we're going to use our calculator to help us. So if I want to expand a plus b to the 4th, I know that I did that up here, but a way to get the coefficients is to type in to your calculator 4 and then your combination button, and you're going to use these brackets with 0, 1, 2, 3, 4 in the calculator to find all the binomial coefficients when n is to the 4th power. I'll show you how to do that here. Bring up my calculator. Oh, there's a nice looking graph. Clear all this old stuff out. All I need to do is type in 4. Then I just hit math, go to the left so that I'm up on the probability portion, and then I want my combination button, which is number 3. And then instead of typing just one r value, I can type in a whole bunch at once. by doing second parenthesis, and then I type in 0, comma, 1, comma, 2, comma, 3, comma, 4. Then I close that bracket again, press enter, and there it gives me all the answers for 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. You got all those answers all at once. 1, 4, 6, 4, 1. So then with that information, I got 1, 4, 6, 4, 1. I can write those coefficients in quite easily and use what I learned from the pattern above. A is to the fourth in this term, a to the third, a to the second, a to the first, a to the 0, and then the b's work the other way. B to the 0, b to the first, b to the second, b to the third, and b to the fourth. And then I'm all done. All that expansion without having to FOIL it all. Pretty slick. You can also get those numbers by using Pascal's triangle. On Pascal's triangle, we start with 1. That's if you raise whatever you have to the 0 power. If you raise it to the 0 power, you've got 1. And then if you remember Pascal's triangle, what you do is you take and you write out the numbers in the gaps formed by the row above. So I'm not sure where I left off there. We had a meeting after school, and that's when I was making this. But so I'll just talk about Pascal's triangle. I believe you've been introduced to this before, and you can keep drawing this out. What you need to know is that how you get the next number is you add the previous numbers. Along the outside edge are obviously 1s. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. 1 and 3 is 4. 3 and 3 is 6, and so on. And you can just keep expanding this out forever and ever and ever. Which is that's a good time all in itself. But basically, what you can see is if you're raising a binomial, that a plus b to the first power, well then the coefficients were 1 and 1. When you raise to the second power, this is the second row, if you will, and the coefficients that you use are 1, 2, and 1. That's the same. Those are the same numbers you would get if you did 2 choose 0, 2 choose 1, and 2 choose 2. So Pascal's triangle gets you the same answers as using your combinations. So basically the big ticket item here in this lesson is the binomial theorem. And the way that works is if you expand a binomial, you simply will take n choose 0 times whatever the first term in your binomial is raised to that nth power, plus, and then that would be the second term in the binomial raised to the 0 power, but it's not written out because it's always 1. The second one to the 0 power would be right there, which you don't have to write out again. And then the second term, so you take n choose 1. Whatever n is, that's the power, remember. And then you'd multiply that by whatever the first term is in your binomial again. So whatever that is, raised to the n minus 1 would go here. And then the b raised to the first power would go there. And the exponent of that first term decreases by 1 each time. And the b, or the exponent of the second term in your binomial, decreases or increases by 1 each time. And in so doing, you can expand your binomial quite easily. So I'll just show you a couple examples of this. And you can copy down whatever you feel you need. If I was going to expand x plus y to the 7th, well, then I would have my coefficient would be, the starting coefficient would be 7 choose 0 for the first term, 7 choose 1 for the second, 7 choose 2, 7 choose 3, and so on, all the way down the line. And my first term in the binomial is an x. So I start with x raised to the n was 7. So I've got x to the 7th, x to the 6th in the second term, x to the 5th in the third, and so on, where the x's go down, down, and then obviously x to the 0 would give you a 0. And then whatever that second term was in your binomial, that starts at raised to the 0 power, and then raised to the first, second, third, all the way up to the 4th. After you write that out, you then simplify it, and you've expanded your binomial. Here's another example. Now, I wanted to include this one because it shows your b value, if you will, being a -2. You do everything the same, but now you're raising, so now in this first term you'd have -2 to the first, then -2 to the 0, then -2 to the first, -2 squared, -2 to the cubed, and so on. And then from there, when you simplify it out, notice when it's negative like that, that ends up making you alternate signs. And you have to, when it's a number, you have to take that number times what you used your combination for, or your Pascal's triangle. So in this case, we had 5 choose 0, which was just 1, so 1 out front. 5 choose 1, well, that equals 5, so that's why that number's out front. 5 choose 2 is 10, 5 choose 3 is 10, 5 choose 4 is 5, 5 choose 5 is 1 again, so no number out there. And then -2 to the 5th, well, that's 32, or -32. 5 times -2 to the 4th, well, that's 80. 10 times -2 to the 3rd, well, that's -80, and so on. Here's one more example. You could have exponents within your binomial. So if I had z cubed, well, that z cubed is your a term. 5x squared, that's your b term. So what you can do is you can look at a plus b to the 5th and kind of set it up in that way and get everything written out, and then you can replace the a's with z cubes, the b's with 5x squareds, and expand out from there. In this case, I think the numbers that are written in are a little off, so I'm not going to reveal any more, but you'd expand in that way. The other types of questions you'll have will pertain to finding a specific coefficient for a specific term. So for instance, if I go back up, I might ask you something like, what is the coefficient on the 4th term in the expansion of x plus y to the 7th? Well, that would be the same as asking about the 4th term in this expansion, which would be the same as asking you to take 7 choose 4 minus 1, which is 3, and then if either term in the binomial was a number, you'd also have to take that number as well. So I wanted to know about the 4th term. If the 4th term in the expansion, if the first term, or that x value in this case, was a number, since I wanted the 4th term, I would have to take that x to the 4th, or whatever that number was, to the 4th, and I'd have to take, in this case, y to the 3rd. So I'm going to ask you some questions like that, which you don't have to write out the whole expanded binomial if you understand where those numbers come from. That's all I'm going to say about that right now. Good luck. Make sure that you get your notes done before you come to class and have questions ready.